Hi friends, today I will discuss about anatomy of the internal ear. First, I will discuss about the where it located uh, um, in the head location, pictus part of the temporal bone. It is middle cranial fossa. This is anterior. This is posterior. This is middle cranial fossa. This is uh, auricle, and here is external auditory meatus. This is middle ear and it is the inner ear. It located in the middle cranial fossa of the temporal bone. Already I said that this is bony labyrinth and middle one is membranous labyrinth. Membranous labyrinth is filled with endolymph and the space between membranous and bony labyrinth there is a space. It is filled with perilymph. Internal ear consist bony labyrinth and membranous labyrinth, and also we can say that it consists vestibular apparatus and cochlear apparatus. Contents. First, this is cochlea and this is vestibule, semicircular canal. Inner ear is made up of membranous bony labyrinth. I will discuss now bony parts. Cochlea is the bony part, and vestibule is the bony part, and semicircular canal is the bony part. Respective membranous part. In the bony part of cochlea, there is membranous part which is called cochlear duct, and the cochlear duct epithelium is modified and forms some sensory part. It is called organ of corti. Its function is hearing. For hearing, this cochlear apparatus is important. Vestibule, it is a bony part. It contains membranous part. There are two membranous parts. One is saccule, another is ventricle. During embryogenesis, a saccule and cochlea is developed from the lower part of the otic vesicle, and saccule and ventricle epithelium is modified to form as a macule. It is a sensory epithelium. Its function is static function. Semicircular canal is a bony part and its membrane part is called semicircular duct, and its sensory epithelium is a crista ampulla, and function is kinetic function, moving function. Static function is without, there is no movement. In kinetic function, acceleration, moving towards, moving forward and backward and downward, and in these situations the semicircular canals are the important parts which mediates these motions. Now only I discussed these parts. Once again I will show in the picture. Please see this picture. This is cochlea and this is vestibule and this is semicircular canals. Now only I told that these are the bony part of the internal ear, that is bony labyrinth. These three parts. A respective membranous part is cochlea contains cochlear duct. This is membranous part, and vestibule contain two parts. One is saccule, another is ventricle. And semicircular canals contain semicircular duct. It is a membrane part of the semicircular canals. Every membranous part has a sensory epithelium. In cochlear duct there is a organ of corti. In the in the saccule ventricle there is a macule, and the semicircular duct consists crista at the end, at the starting of the circular canals. I draw membranous labyrinth in the red color and the bony labyrinth in the blue color. Now discussing the one by one. First I will discuss cochlea. Uh, how it looks like. It looks like it resembles as a snail. ఎప్పుడన్నా వాన పడినప్పుడు మనము ఇవి చూడొచ్చు అనమాట. నత్తలు ఎలా ఉంటాయంటే సేమ్ కోక్లేలాగా ఉంటాయి అనమాట. ఓకేనా, ఇట్లా ఉంటాయి అనమాట. అందుకే ఇట్ రిజెంబుల్స్ యాజ్ ఎ స్నేల్. ఒక బోనీ పార్ట్ ఉంటుంది కోక్లియాలో, దాన్ని మోడ్యులస్ అంటాం అనమాట. బోనీ పార్ట్ ఒక కొనికల్ షేప్లో ఉంటుంది. దిస్ ఈజ్ కాల్డ్ మోడ్యులస్. ఇట్ హ్యాస్ అపెక్స్ అండ్ బేస్. అపెక్స్ ఈజ్ towards middle ear, anterior superior part of the middle ear, and its base part towards the internal acoustic meatus. It runs forward and laterally in the middle cranial fossa, vitreous part of the temporal bone. The cochlea is turned like this. It turned around the modiolus bone like this. The cochlea is turns around the modiolus bone like in this picture. If I cut this part, cochlea part, along with modiolus bone longitudinally, it looks like this. This is modiolus, this is cochlea, 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 cochlea. In the base part, the cochlea is large and the apex part is small. If the cochlea is going from base, if you grow from the base to the apex, in the apex there is no membranous part. Directly this scala vestibule is communicate with the scala tympani. At that point is called helicotrema. When you go to the apex, there is no membranous part. Directly scala vestibule communicate with the scala tympani. At that point we call it as a helicotrema. From the modiolus bone there is a how this scala vestibule and scala tympani form. This formed due to the separation by the one of the modiolus bone projection. This modiolus bone projection is called spiral lamina. Due to this spiral lamina only, cochlea is divided into scala vestibule and scala tympani. This scala vestibule and scala tympani filled with perilymph. Already I discussed that. This is scala media. This is membranous part. It filled with endolymph. And this upper membrane which is extend from the spiral lamina to the outer cochlear membrane. It is called Reasoner's membrane. This below membrane is called basilar membrane. Already I told that The sensory epithelium of the cochlear duct is called organ of Corti. The organ of Corti is located on the basilar membrane. This is the cochlea organ of Corti. It is basilar membrane. Reasoner's membrane is less elastic. It is more elastic. Which one? Basilar membrane is the more elastic. This is the region when the sound waves coming from the out from the middle ear to the inner ear, it travels from the scala vestibuli and it comes into the scala tympani. During that time there is no vibrations in the regional membrane. This is the reason why it is not elastic. uh, Basilar membrane is elastic. So when the sound waves coming from the scala vestibuli and it reaches to the scala tympani, where the uh, membrane is vibrating. Why? Because this basilar membrane is more elastic. So when the sound waves reaches to the scala tympani, there is starting the vibrations from the basilar membrane, which produces the mechanical energy. This mechanical energy converted into the electrical energy, which the electrical energy received by the cochlear nerve. Next, I will discuss about the detail about the organ of Corti. This is membranous part. This is bony part. This membranous part filled with endolymph. The space between the membranous labyrinth and bony labyrinth, there is a space which is filled with perilymph. Now I will discuss the duct of the cochlea. What is the components of the duct? This is the membranous part of the cochlea is scala media. The scala media is bounded upside by the resonance membrane and down. Base it is formed by the basilar membrane. It is the stria vascularis. This endolymph is fills the scala media, which is produced from the stria vascularis. Uh, Above the basilar membrane, there is a sensory epithelium which is called organ of Corti, which has the supporting cells. For example, this is basilar membrane. Above the basilar membrane, there are rows of the supporting cells. First, there is a single row of supporting cells, and there is a gap, and after that there is a 3 rows of supporting cells which continues along the basilar membrane. Above the supporting cells there is a hair cells, one row of hair cells on the supporting cells and 3 of hair cells outside of the along the basilar membrane. There is a space between inner one hair cell row and outer 3 line hair cells. There is a space. It is called tunnel of Corti. Tunnel of Corti. and both this row and this row is covered by the one sheet like sheet like cloth or sheet like sheet which is called tectorial membrane. What is the importance of tectorial membrane? When there is a sound waves coming from the middle ear to the inner ear, which travels from the scala vestibuli to the scala tympani, where it produces the vibrations in the basilar membrane. These vibrations are reaching to the organ of Carti, while these vibrations also reaching to the tectorial membrane. With, uh, when the vibrations reach to the tectorial membrane, it pulls the hair cells, which this mechanical energy converted into electrical energy, which taken up by the peripheral process of the peripheral process of the cochlea nerve, which leads to the spiral ganglia and eventually leads pass through the cochlear nerve, which goes to the central process and assess the hearing. This is the scala media, that is duct of the cochlea. uh, One thing I forgot, that is stria vascularis produces endolymph. This process requires some melanocytes. In the albinism disease, there is decrease in the melanocytes. So when there is decrease in the melanocytes, already we know that this process requires melanocytes. There is decrease in the albinism. There is decrease in the melanocytes, which leads to the decrease in the production of endolymph. This decreased production of endolymph leads to the deafness. So albinism is associated with deafness due to the melanocyte link. Now I will discuss about the vestibule. Vestibule contain both saccule and utricle. This in the internal ear, the vestibule is the middle part between semicircular canals and the cochlea. This vestibule is lateral side of the vestibule is opens into the middle ear through the vowel window. This vowel window in the middle ear, this vowel window is attached with stapes. When the sound waves come from the auricle, it enters into the middle ear where it process this transmitted to the stapes, which eventually through vowel window it enters into the scala. This enters into the vestibule. From there it spreads to the cochlea, and from upwards it spreads to the semicircular canals. This sound for hearing, and this semicircular canals is for equilibrium. The membranous part of the vestibular, one is saccule, another is utricle. Already we discussed. And saccule has macule as a sensory epithelium. This in the saccule, it is arranged as a vertical. I will show how it arranged. This is saccule. This is utricle. Always saccule is smaller and utricle is larger. This is utricle. I show how the sensory epithelium is arranged in the saccule and how the sensory epithelium is arranged in the utricle. This is the arrangement of epithelium in the saccule. This is the arrangement of sensory epithelium in the utricle. This uh, hair cells in the saccule lateral side. This is the upper side stereocilia. So that is the reason why the saccule is involved in the only vertical motions. It is involved in the while we are in the lift. It is work in the this direction and this direction. This is about membranous part of the vestibule. This is the peripheral process which accept the impulse from the that membranous part. This upper part of the stereocilia covered by the gelatinous substance which consists it is rich in calcium carbonates, so it is called otoconia. It is the responsible for any impulse production. These are the static motions. Now I will discuss semicircular canals. These semicircular canals, they are 3 in one year and another 3 in another year, total 6 in number. In this, one is horizontal or lateral semicircular canal, one is anterior or superior, another is posterior. This is the arrangement of the semicircular canals. This eventually open into the vestibule. One point is this membranous part of the internal ear is completely closed, total along the internal ear. These are the alignment of the semicircular canals. This is lateral or horizontal semicircular canal. This is also horizontal semicircular canal. This is the anterior or superior. This is the posterior. Always these two horizontal semicircular canals is always aligned in one plane. And this posterior of the this is left, this is right. Posterior of the left and anterior of the right, same like that only. Posterior of the right and anterior of the left. This is the alignments planes of the semicircular canals. This semicircular canal has semicircular duct. As semicircular duct is membranous part, and it has a sensory epithelium is called crista. Above the crista ampulla there is a gelatinous part which is called cupula. This has a stereocilia and kinocilia. This helps in this detail. These semicircular canals are help in the detect the motion in the head movements in the vertical plane and right. This if the head is rotated towards the shoulder. Then these two horizontal semicircular canals is help in the if there is head in వర్టికల్ పొజిషన్లో ఉన్నప్పుడు ఈ హారిజంటల్స్ అనేటివి వర్క్ చేస్తాయి. అదేవిధంగా పోస్టీరియర్ టు యాంటీరియర్ మూమెంట్స్లో మనకి ఈ యాంటీరియర్ సెమిసర్క్యులర్ కెనాల్ అనేది వర్క్ చేస్తుంది. అదేవిధంగా మనకి ఇప్పుడు లెఫ్ట్ టు రైట్, ఇప్పుడు తలని మనము భుజానికి ఆనించినప్పుడు ఈ పోస్టీరియర్ సెమిసర్క్యులర్ కెనాల్ అనేది వర్క్ అవుతుంది అనమాట. బ్లడ్ సప్లై మామూలుగా టూ స్పైనల్ ఆర్టరీస్ అనేటివి కలిసి ఇక్కడ మనకి బేస్లర్ ఆర్టరీగా ఫామ్ అవుతుంది. ఇది ఆ తర్వాత ఫాంటైన్ ఆర్టరీస్ అట్లా వస్తుంది. ఇక్కడ ఒక బ్రాంచ్ వస్తుంది, దాన్ని ఏమంటామంటే లాబ్రింథైన్ ఆర్టరీ అంటాం. ఈ లాబ్రింథైన్ బ్రాంచ్ అనేది ఇంటర్నల్ అకోస్టిక్ మియేటస్ ద్వారా ఎంటర్ అయ్యి అది కోక్లియాకి అన్ని దాంట్లోకి సప్లై చేస్తుంది అనమాట. నౌ ఐ విల్ డిస్కస్ అబౌట్ ద స్ట్రక్చర్ ఆఫ్ సెన్సరీ ఎపిథీలియం. దిస్ ఈజ్ ద స్ట్రక్చర్. ఇట్ కన్సిస్ట్ లాంగ్ process, it is called kynocelia, and shorter process are called stereocilia. This is structure of the cell in the sensory epithelium. If this hair cell is turned in this direction, potassium pumps open, the Ka plus enters inside. If this enters inside, the resting membrane potential is converted into depolarization and excitation. If this hair cells is turned in this direction, K plus channels are closed. And the potassium is not come inside, so it leads to the hyperpolarization. This is the structure of sensory epithelium. Already I discussed macula has hair cells and supporting cells. Below this it has gelatinous substance which is the rich in the calcium carbonates. It is called otoconia. It receives the detect the movements of the head, hearing. First auricle receive the sound waves. Middle the middle there is oscular chain, malleus, incus, stapes. This sound waves transmitted to the oscular chain reaches the this is the oval window, this is the round window, this is the vestibule, saccule, elliptical and semicircular canals. from here the sound waves reaches the scala vestibule. At the helicotrema, it reaches to the scala tympani where the vibrations reach to the basilar membrane. From the basilar membrane, there is an organ of Corti where the mechanical energy converted into the electrical energy. From there, this impulse is transmitted to the spiral ganglia. From the spiral ganglia, it reaches to the cochlea. Cochlea is goes to the central nervous central process where this hearing process is assessed. This is the anatomy of the internal ear. Thank you for your patient listening. Watch the remaining future videos and learn the basics.